Okay, up next, we have Alexandr Shukhotskiy, delivery manager at EPAM. And if you're a builder, architect, or a visionary looking to understand how to design blockchain infrastructures that are scalable and secure enough to serve millions, this talk is for you. Welcome on stage, Alexander.
Thank you, Farouk. Hello, everyone. I hope you're all doing marvelously well. I'm excited to join this awesome event as one of the speakers. And today I'm going to share my experience building a central bank digital currency for one of the countries, which name I unfortunately cannot reveal because of NDA. But anyway, in one of my previous jobs, I served as a head of engineering for CBDC development project. This means that I was there from the proof of concept stage to a pilot-ready system. And during various stages of this project, I played several roles based off its needs. So I was a solution architect, a principal engineer, an engineering manager. So I built a team to move this project forward. And that means that I have a comprehensive perspective on various aspects. So this project, this product evolved constantly, sometimes because of political regulations, sometimes because of technical drawbacks and so on. And this led to me and my team rebuilding the solution multiple times over the year. So in the end, it was like multiple proof of concepts, at least 2 MVPs before we reached a pilot stage. So I'm going to share some lessons that I've learned along the way. I believe these will be interesting, insightful. So here we go. So what is CBDC? Let me start with some fundamentals. So CBDC, an acronym or abbreviation for central bank digital currency. It's not a cryptocurrency. It's just a digital form of fiat money, usually issued by some governmental entity or central bank, and it's backed one-to-one by real money. CBDCs don't have to rely on blockchain at all because digital doesn't mean decentralized or blockchain driven. So if we talk about known CBDC projects across the world, then some of those are just a system relying on traditional data storage, perhaps relational database or NoSQL, because it's quite difficult uh, to accomplish the goals that I will talk about later when relying on blockchain. Also, what I want to say next. Let me see. So CBDCs are usually, I would even say always, not mineable. They're not tradable. Also, CBDCs don't operate on public chains. Usually it's something permission-based, private networks. And also there are different models, retail versus wholesale. Like retail CBDCs can be used by individuals as well as businesses. Wholesale CBDCs usually are here just to allow for some interbank money transfers, something like that. Also, uh, some CBDCs allow for dynamic conversion, like when you trade 1 unit of fiat currency to get 1 CBDC coin. And also CBDCs can be managed by banks that usually form digital funds to back it up. So speaking of technology foundations, as I mentioned, CBDCs that are driven by blockchains are usually permissioned, not public. So we are falling into the realm of something similar to Hyperledger, Corda, etc. And when you have to pick a technology to rely on, then you're very, very likely want it to be open source. Why? Because open source means cost effective, transparent, auditable. You gain huge community support because uh, usually when we talk about CBDCs, it means that the main entity behind it is something like government. So it's usually B2G customers. And those entities cannot allow for hiring expensive teams. Also, sometimes only people from specific countries with specific passports can be hired uh, because it's like very sensitive. Usually, governments care about not having any leaks. So it's quite complicated. And when you rely on open source, that also means that you have almost free access to the brightest minds in the industry that otherwise you won't be able to have on your team. Uh, so let me continue. So for this particular CBDC project that I'm speaking about, IBM Hyperledger Fabric was selected as the primary blockchain technology. And now I want to talk about some trade-offs. So when you want to develop a nation-scale blockchain-driven payment system, you usually want it to be both high trust and high performance. However, there is always a trade-off between the trust and the speed, the performance, call it whatever you like. Because if you want your system to be high trust, that means that you have to put all the logic, almost all the logic, at least the most crucial one, into smart contracts so that it's on chain. And you cannot have it, let's say, as gateway layer or anything surrounding your blockchain, because otherwise you can compromise data whichever you like. So let's imagine you have your logic in some microservice, and all that you have on chain is just recording it, storing it in the ledger. That means that participants of such blockchain systems cannot verify whether data was manipulated. It's just save and store it, nothing else. So it's better to move the logic on chain. In that case, the system will be higher trust, and also there will be such thing as endorsement policy, consensus. I will speak about later. But on the other hand, when you place more logic into smart contracts, the performance may decline, because usually it means that you will have quite a few disk input-output operations. Also, since the nodes of the blockchain system communicate with each other to reach consensus, it means multiple calls. So it will cause bigger latency, higher latency, and the system will be less performant. Also, I want to say a few words regarding endorsement policy patterns. So, concerning IBM Hyperledger Fabric, it's configurable, and usually it's either the majority or some combination of supervisor peer plus any number of regular member peers. And the more nodes, the more peers are required for endorsement policy for consensus. The slower is the system, but the more trustable it is. So, elaborating on what I previously said, when the teams that don't have much experience with CBDCs develop something like CBDC for a given country, they may default to widely used architectural patterns, principles, and so on, treating smart contracts as microservices that would be split by domain. So let's say wallet microservice, payment microservice, something like that. And this could result in multiple smart contracts creation. Also, I want to share with you another term that is used mostly when referring to IBM Hyperledger Fabric smart contracts. This term is chain code. So chain code is a piece of code that is deployed to the Hyperledger network, that stores some logic, that has access to the ledger, to the blockchain, and so on. So when the teams adopt something similar to microservice approach, they create multiple chain codes, deploy those to the network, and then experience some significant performance drawbacks, because when chain codes communicate with each other, those calls should just be multiplied by the number of peers that is needed to reach the consensus and that is needed for endorsement policy to be successfully applied. That's why it's better to have a single monolithic smart contract or chain code that will have access to all the data. And if there is a need to have granular smart contracts or to allow participants of the chain to deploy customly developed smart contracts, then you have to consider something like creating your own language or defining those contracts, maybe something JSON based that could be stored in the chain. Then it could be read by monolithic chain code, and the logic could be executed by this monolithic contract. However, microservice approach can still be applied and be used to great success if we speak about the transport layer. So microservices are great for developing and deploying some micro gateways that will be running on the nodes of CBDC system participants, because these could allow for greater flexibility and I would say more effective security control, because CBDCs can have participants among different institutions that would require custom tailoring their permissions. So you can have one regulator or a supervisor that should have like master access to the system, and you may have other participants like regular banks that should be able to execute only limited range of operations. In this case, you can deploy certain microservices to certain servers belonging to particular members of the system, and you can deploy everything to supervisor servers. So usually microservices are there just for some form of orchestration and usually act as just proxies. So let's say a mobile banking app can send a request to the corresponding bank infrastructure, and there you may have a microservice that would then use some crypto materials to connect to a chain code running on one of the peers of CBDC network. Okay, so let's move on. When developing components that would be running on chain, it's important to keep in mind that the code must be absolutely deterministic, because the code is being executed on multiple peers. Those peers could have slightly different timestamps when it's going to code executions, and this may lead to discrepancies which would result in aborting the operation. So it's better to never use something like, if we speak about Go programming language, something like time.now. And usually uh, technologies such as IBM Hyperledger Fabric have their own uh, safe functions to rely on when you need to get dates and times. Also, when speaking of randomization, let's say there's a need to um, generate random identifier to act as account ID or wallet ID. It's also required, absolutely required, to rely on seeded randomization, because if endorsement policy is applied and there are multiple peers required to reach consensus, then each peer will randomize its own value, and there will be discrepancies again that would make transaction obsolete. So speaking of programming language of choice, I have experience with Golang. Why? Because it's pretty lightweight, pretty performant, and what's even more important, it's a native programming language that of IBM Hyperledger Fabric. So it would allow for smooth integration. All you have to do is just import Hyperledger SDK package, and then you can communicate with your chain codes and so on. So what else I want to mention is that it's better not to have any external calls from chain codes or from your smart contracts, because of the nature of endorsement policy, those will be repeated multiple times. So imagine making a call to store something in the database, and as a result, you will save something multiple times. Also, one important thing that I want to mention is cryptography. IBM Hyperledger Fabric allow for a change of cryptography. So you can either rely on something called Fabric CA. This is native Hyperledger's tool for checking whether any participant is allowed to connect to the network, to execute operations, to call chain codes, and those certificates can be replaced with some external certificate providers. So when we are talking about nation scale CBDCs, usually there are regulations that could force you into national cryptographic solutions, and IBM Hyperledger Fabric allow for this swap. So there are also known drawbacks and nuances of IBM Hyperledger Fabric technology. You have to design your system in such a way that collisions and read-write conflicts are avoided. So when you call a chain code to execute some logic that will result in the transaction being created and submitted to the chain, there is some time buffer, time slag before this data would reach blockchain. And because of that, any other transactions initiated within this time frame and using same keys, same objects, same entities, they will be discarded. So let me provide you with an example. Just imagine something like Walmart or any other um, high transaction entity. So usually there are requirements from the government that each entity should be associated with only one identificator. And since everything is stored as key value pair in the world state of Hyperledger Fabric, then when you want to modify this key and let's say read it at the same time, then this will result in a conflict. Also, if you want to modify this key and then someone else wants to modify this key as well at the same time or within the time that is required to push a new block to the blockchain, then this transaction would also be aborted. So this whole situation is not good because just imagine you have something like Walmart. This entity has one wallet in your blockchain system, blockchain payment system, and this wallet is associated with some key in the world state of your blockchain. And then when you have multiple money transfers involving this account, you will have hundreds of key collisions, hundreds of conflicts. And this could result in only one transaction being successfully executed and committed, and all the rest would be rejected right away. And this could lead to hundreds of customers being angry, and this could also paralyze the entire flow of such huge entity as Walmart. So what could be a solution? You may want to allow for decentralized initiation of a payment transaction, and then you may want to introduce a centralized mechanism that would then iterate through all unprocessed transactions and execute them in a cycle. So imagine like your first phase, first stage. You just record something. Let's call it like an intent. Like you're recording an intent of someone to perform a payment. So this entity is being saved in the blockchain. No conflicts because you're working only with one unique key at a time. Just recording your intent to buy something or to sell something or just to transfer money. And then 1 or 2 seconds later, some centralized script triggers a chain code to execute all transactions that are pending. In this case, these transactions will first be fetched. Actually, not transactions, payment intent entities. They will be fetched and then processed in memory. And once everything is processed in memory, you now can push it to the blockchain. And in this case, you won't have conflicts. However, this approach makes it difficult to horizontally scale the system because it will always have a bottleneck in a form of centralized entity that triggers execution of pending payments. So in this case, I drew a hypothetical architecture of a CBDC system that is pretty close to real world pilots. So you can see that there are multiple participants. So you can see one bank. I called it JP Morgan Chase. Another bank, like let's call it Citibank, and also a centralized authority, federal bank. So every participant will store crypto materials for authentication, authorization in the system. A bunch of microservices to act as a gateway between the user calls and Hyperledger network chain codes. So I intentionally limited the number of deployed microservices for regular CBDC system members. And as you can see, centralized authority or a supervisor have these admin microservice which allow for some extra functionality. So deployment is pretty flexible. Also, supervisor may have something like cron jobs or scheduled tasks that would periodically trigger the logic available only to this supervising entity. So as I mentioned earlier, payment initiation can be decentralized. So you can see like a CBDC Pay API. This will result in pending payment entity creation, and a supervisor will be able to then call the chain code, a specific chain code to execute all pending payments. So usually when there is a new call to the system, it will be transferred to the corresponding CBDC system participant peer that would then execute chain code or smart contract logic This will result in so-called read-write set creation that will then be distributed across other peers to apply endorsement policy to verify whether all keys that were read from the world state or from the ledger and all the keys that were written to it match each other. And once endorsement policy is successfully applied, then there is another call to order and service to order transactions and push them to the block. Also, there is a membership service that could either rely on internal Hyperledger cryptography or rely on some external certificate authority, and basically that's it. So reflecting on my experience, I want to say that using blockchain for CBDC system creation is quite an interesting experience. However, there are certain drawbacks because usually when we speak about public blockchains, they just have to provide some degree of anonymity, transaction speed, transaction creation speed is not that important as long as money are transferred safely and anonymously. So if we speak about something like Bitcoin, I could be mistaken, but I believe certain transactions require multiple minutes just to be processed and committed to the chain. But if we speak about something that require supervision from the government, then public blockchain principles are not the answer here. But again, maybe it's a good practice to rely on blockchain only as a source of truth and still keep everything the old school way, like some backend, some database, traditional database, and then have blockchain for auditioning. So in this case, you store just some hashes in the blockchain, hashes of the data that is also stored in other data storages, and once in a time, certain institutions use it to audit the system to ensure that there is no corruption, nothing malicious was done, and so on. But again, what I want to say is that CBDCs perhaps might increase or may elevate the role of blockchain. So it's not longer about just startups or some DeFi's. It's about regulated high trust systems. So basically, that's it. Thank you for your attention.
All right, Alex. Very sorry, but we do not have any time for the Q&A. We've got some couple questions in the chat, but I'll ask everyone in chat to address your questions directly to Alex. I'll create a separate topic in our Telegram group if you don't mind, of course, Alex. Are you okay with this?
Yeah, sure. I won't be able to answer all the questions due to NDA, but I think I will at least be able to share some anonymized experiences.
Okay, perfect. This works with us. And thank you, Alex, for the deep dive into the complexities of building the nation scale blockchain infrastructures and also sharing the fundamentals in the beginning. It was very useful for me personally. Thank you. You have a great one, and you will always welcome back on our stage at Blockchain Professionals.
Thank you. Thank you.